Your brain, constituting about 75% water and resembling the texture of a soft-boiled egg, comprises roughly 100 billion nerve cells, known as neurons, intricately arranged within an aqueous environment. Each neuron bears resemblance to a leafless yet flexible oak tree, with its branches and roots forming connections with other nerve cells. The number of connections a neuron establishes can vary significantly, ranging from $1,000 to over $100,000, depending on its location in the brain. For instance, the neocortex, responsible for cognitive functions, boasts approximately 10,000 to 40,000 connections per neuron. Previously likened to a computer, we now recognize the brain as far more complex. Each neuron functions as a distinct biocomputer with over 60 megabytes of RAM, capable of processing vast amounts of data, up to hundreds of thousands of functions per second. As we acquire new knowledge and undergo novel experiences, neurons form new connections, exchanging electrochemical information through synapses, the junctions between neuron branches and roots. Learning involves establishing new synaptic connections, while memory entails maintaining these connections. Essentially, a memory represents a long-term relationship or connection between nerve cells, influencing the brain's physical structure over time. As the brain undergoes these changes, our thoughts trigger the release of various neurotransmitters such as serotonin and dopamine, facilitating communication between neurons. When neurons collectively support a new thought, a protein is synthesized within the nerve cell and interacts with the cell's nucleus, activating several genes. These genes encode proteins essential for maintaining the body's structure and function, prompting the nerve cell to create new connections with neighboring neurons. Consequently, repeated thoughts or experiences lead to the formation of stronger and more numerous connections between neurons, enriching the brain's microscopic landscape. Thus, the act of thinking new thoughts initiates neurological, chemical, and genetic changes. With novel learning and fresh experiences, thousands of new connections can be gained in a matter of seconds. This underscores the profound impact of thought on gene activation, a phenomenon occurring simply through the act of changing one's mind. According to Nobel laureate Eric Kandel, MD, the formation of new memories doubles the number of synaptic connections in stimulated sensory neurons. However, unless the initial learning experience is reiterated, the number of new connections reverts to its original state within 3 weeks. Hence, consistent repetition is crucial for strengthening neural communities and preserving memories. To grasp the immense scale of this neural system, envision a single nerve cell linking to 40,000 others, processing and sharing vast amounts of information within a neural network, an intricate web of synaptic connections, also known as neurocircuitry. As neurons adapt and organize into intricate networks capable of processing extensive data, the brain's physical structure undergoes continuous adaptation, shaped by environmental input. Over time, as neural networks are repeatedly activated, the brain maintains its hardware, the physical neural networks, while also developing a software program, an automatic neural network. This dynamic interplay between hardware and software reinforces the brain's functionality with each use. When you consistently entertain the same thoughts and experience the same emotions without engaging in new activities or learning, your brain follows familiar patterns, sequences, and combinations, activating neural networks in repetitive ways. These patterns become automated programs that operate unconsciously in your daily life. Tasks such as speaking a language, grooming, typing, or making judgments become effortless because they have been performed so frequently that they require little conscious effort. With repetition, these neural circuits become firmly established, with connections between neurons strengthening and additional circuits forming. This process resembles reinforcing a bridge, constructing new roads, or expanding a freeway to accommodate increased traffic. A fundamental principle in neuroscience emphasizes that nerve cells that fire together wire together. This means that when your brain repeatedly engages in the same firing patterns, it reinforces a consistent state of mind. In neuroscience, the mind is viewed as the active functioning of the brain. Therefore, if you consistently reinforce your self-perception and identity through repetitive thought patterns, you activate the same neural networks consistently over time. By the time you reach your mid-30s, your brain has developed a distinct set of automatic programs, forming what is commonly referred to as your identity. Conceptually, envision this process as creating a figurative box within your brain. While there isn't a physical box inside your head, the analogy illustrates how repetitive thinking can confine your brain to a limited pattern. Essentially, thinking inside the box suggests that you have solidified your brain's functioning into a fixed pattern, constraining your cognitive flexibility and potential for novel experiences. Through repetitively generating the same mental state, the neural circuits that are frequently activated have essentially shaped your identity through your conscious choices. If your thoughts, choices, behaviors, experiences, and emotional states remain stagnant for an extended period, consistently leading to the same feelings and perpetuating a repetitive cycle, your brain undergoes a process of fixed wiring. This occurs as your brain repetitively fires in predictable patterns, reinforcing specific neural networks and cementing a predetermined level of consciousness. Essentially, you're confined to a rigid mental framework, commonly referred to as your identity, formed by these entrenched circuits. Our objective, therefore, should be to engage in thinking that diverges from conventional patterns, allowing the brain to operate in novel ways. This concept of having an open mind involves actively prompting the brain to function differently, effectively altering one's mindset. Scientific research supports the idea that the brain is malleable and capable of change through a phenomenon known as neuroplasticity, where it adapts and evolves in response to new information and experiences. For instance, prolonged engagement in specific activities, like mathematics or music, can lead to the growth of neural networks associated with those skills. By embracing new learning and adopting fresh perspectives, individuals stimulate diverse networks of neurons, thereby reshaping their cognitive processes. This shift in thinking outside the conventional framework initiates a cascade of changes, influencing choices, behaviors, experiences, and emotions, ultimately leading to a transformation in one's identity. Neuroplasticity operates through mechanisms of pruning and sprouting, wherein unnecessary neural connections are eliminated while new ones are formed, a process demonstrated in studies on animal enrichment. To overcome ingrained patterns and conditioning, intentional effort and acquiring knowledge are essential. Learning about oneself and the world introduces new elements into the brain's intricate structure, offering additional resources for navigating life with a renewed perspective. This expansion of mental horizons allows individuals to interpret reality through the lens of a fresh mindset. At this juncture, it becomes evident that effecting change necessitates a heightened awareness of our ingrained subconscious patterns, which essentially dictate our behaviors and responses. The greatest challenge in this process lies in deviating from the familiar choices we habitually make day after day. The discomfort arises when we consciously disrupt the cycle of repetitive thoughts and actions that reinforce our existing identity and emotions. Stepping into this uncharted territory feels unsettling and foreign as it deviates from our accustomed sense of self. This discomfort signifies our transition into the realm of change, where we confront the unknown. It's not an instantaneous transformation, but rather a gradual journey. Embracing change entails relinquishing the safety of our familiar self, characterized by predictable thoughts, behaviors, and emotions, and venturing into the uncertainty of new possibilities. This transition marks the symbolic death of our old identity, prompting the emergence of a fresh self imbued with novel thoughts, choices, behaviors, and emotions. Embracing the unknown offers the fertile ground for creativity and innovation, as it is only in this realm that we can truly craft something new and transformative. Typically, when individuals embark on the journey of change, they often find themselves swiftly retreating to their old ways due to the discomfort of traversing the void between their former and emerging selves. This discomfort triggers familiar thoughts of unease and disorientation, prompting an unconscious return to familiar behaviors and emotions. Despite labeling this regression as feeling right, it's merely a reflection of familiarity rather than true alignment with one's desired path. Understanding that this discomfort signifies the dismantling of old patterns ingrained in our biology and psychology empowers us to confront change with resilience. Recognizing that this process entails rewiring our neural pathways, challenging entrenched beliefs, and enduring physiological withdrawals equips us with the fortitude to persist. Moreover, comprehending that we are reshaping not only our present but also our genetic legacy, often described as the dark determination and resolve. This transformative phase symbolizes the demise of the old self to pave the way for a rebirth. Embracing the unknown as a realm of infinite potential allows us to harness the creative power within. Instead of shying away from uncertainty, we learn to embrace it, recognizing it as the fertile ground for innovation and growth. Embracing this void signifies a departure from our comfort zone, enabling us to shape our future rather than passively predicting it. As we forge ahead, we undergo profound biological and psychological changes, sprouting new neural connections, cultivating unfamiliar emotional states, and signaling our genes to adapt to our evolving reality. With each dawn, we emerge from the darkness transformed, embodying a renewed self. This metamorphosis transcends mere change. It represents the essence of true transformation, wherein we become architects of our destiny and authors of our narrative. Looking at the brain from another perspective reveals its role as a reflection of our accumulated knowledge and life experiences. Each interaction with the external world leaves an imprint on the intricate network of neurons, forming countless connections that encode our memories. Essentially, the brain serves as a living archive of our past, cataloging every encounter, place, and event. As a result, many of us find ourselves operating from a framework rooted in past experiences, relying on familiar hardware and software programs shaped by our memories. When our daily routines mirror those of the past, we unwittingly allow our external environment to dictate our internal world. This subconscious process perpetuates a cycle wherein our outer realities mold our personalities, reinforcing familiar patterns of thought and emotion. This dynamic creates a symbiotic relationship between our inner and outer worlds, leading to a sense of entrapment wherein our surroundings dictate our thoughts and feelings. To effect change, we must surpass the influence of our current environment by introducing elements that surpass its limitations.